I've defined here sorry, Z is, there was a mistake here. Z is 2.825. So let's edit this. You see, there's a mistake. So let's edit this. Okay, so this is that. Okay, you need to be checking what you're doing. Check what you are loading to make sure there's no errors. So the Z coordinate here is supposed to be 2.825. Okay, that's okay. So let's define this area, and then lastly we're going to define this region. So come back here again, floor load minus 2.5. We are putting in the minimum and maximum X as before. Minimum and maximum X coordinates within the region which you are trying to define as a floor panel. We also specify the minimum and maximum Z values. Okay, I've defined that region. Let me define this last one. Here X is minus 17.78, and then here 28.235, correct, and then Z is 4.251 minimum, and then maximum Z here is 10.277. All right. Fantastic. Hold on. There appears to be a repetition. You see, if you look at this load I clicked on, loaded here. When I click on this, it's also loaded here. You see, there's a mistake. So we need to check where the error is. Once you see all these duplication of loads, it implies that your region definition in space of the corresponding panel is wrong. So let's check. My intention is to load this location only. So come back here, edit. Let's see where the problem is. Minimum X coordinate here is 17.78 and not minus. So this is where the error is. So delete that and change. You see, correct. So we are fine. So we haven't loaded this void. We've corrected this error. So these are the type of quality assurance checks you will carry out in your engineering analysis before you perform any analysis, to make sure that your structural design is accurate, is indicative of the load pattern, philosophy, structural modeling stiffnesses, and so on, support restraints, etc., so that you do not have any errors. So the dead load on the slab, on the roof beams have been broken down correctly to represent exactly the locations where they actually apply. In the same vein, I will have to do that on the live load. You can see that the live load has been applied everywhere. It has been applied everywhere. we would have to, okay, so the life load will be correct. You know why it is correct? Let's look at why it is correct. Now, like we said, the architectural roof layout shows that you have roof over the void. So if there is a maintenance in future where the owner of this structure intends to maintain this roof location above the void, you would have life loading on this location, which will transfer to this beam. So the life load is correct. Okay, so our life load application is okay. Next, you move to the 3rd floor. You check all your floors to ensure everything is correct. This is the slab dead load on the beam on 3rd floor. That's okay. Slab life load on the beam on 3rd floor. Intensity is 1.5. Is okay. The wall load on the 3rd floor. That's fine, and so on. So we are all right. We are okay. So next thing to do is to carry out the load combination. Now the load combination must be in compliance with BS 8110. Let's look at the code of practice to see what the code's instruction is. Remember, this design is in line with the British Standard Code of Practice, BS 8110 Part 1 1997, structural use of concrete. There's the Euro Code 2, which is most common, is the most recent code of practice for the design of concrete structure as provided by Central European Nominal CEN, that covers the design of reinforced concrete structures in line with limit state design. It's an improvement of the British Standard Code of Practice, and that is what is currently being used in most of Europe and for multinationals operating in Nigeria. As we speak currently, the Eurocode 2 is also being revised in line with the British exit of European Union, a code of practice that is under construction now by researchers, professors of structural engineering, and consultants. Is being done currently to replace, is being prepared currently to replace the Eurocode 2. This is an information you're getting from this training because we are in line with most recent engineering updates in structural analysis. Now, the load combination, let's look at what the code says. If you look at section 2.43, it is very clear what the load combination is for the ultimate limit state requirements. So you design under ultimate limit state. Ultimate limit state considerations are considerations that cater against flexural failure, shear failure, fatigue deformation of the structure, and so on. Partial factors of safeties are applied to the characteristic loads, and these loads that provide design bending moments, design shear forces, design torsional and axial forces are used to design the structure entity against design shear stresses, design bending moments, resistances, and so on. So the code states that for dead and imposed load, your factor of safety, so dead and imposed load, your factor of safety is 1.4 for dead and then 1.6 for life. Dead and wind. Now, when you're applying dead and wind, it's very essential to check if the dead load is beneficial or if it creates an adverse effect. So for dead and wind load, if it's beneficial, the code of practice says that the partial factor of safety you apply to dead load is 1.4, that for wind is 1.4, dead, life, and wind, the factor of safety is at 1.2. However, if you're designing structures like portal frame structures where you have wind loads to create an uplift effect, and that you're combining that with dead load, which will be creating a beneficial effect to the uplift onerous case for wind loading, then you're going to use the partial factor of safety of 1.0. That doesn't apply to what we are doing currently. So you create a load combination, go to load case, view your entire structure, add, you go to define combinations, Let's call it combination 100. Let's start with serviceability limit state combinations. So we'll start with dead and life, self weight, roof slab dead load. They're all dead loads. We call them 1.0. Factor of safety is 1, beam finish is 1, imposed load is 1, slab dead, these are dead load, slab life load, wall load, dead load on beams on first floor, dead load on beams on second floor. 10 and 11, they are all dead and life load. So this is dead and life load combination. The partial factor of safety for dead and life load combination under serviceability limit state criteria is 1.0. Okay, so the partial factor of safety under serviceability limit state consideration is 1.0. So once you create a load combination, so this is dead and life, you add, we'll create dead and wind. So dead 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Dead and wind in one direction. So dead and wind load in the X direction is one load case, is one load combination. We call it combination 200. You add, you now create dead and wind load in the Z direction. So each wind load corresponding with the combination dead load will be acting in one direction at a time. So we are creating dead and wind in the Z. We've done in the X, now dead and wind in the Z. Remember, this is serviceability limit state consideration. We call this combination 300. Now we're now going to create dead life and wind in the X, and then we'll create dead life and wind load in the Z direction. So dead life and wind in the X. Oh, a mistake has been made, sorry. We have made a fundamental mistake. If you look at what we have created, we have actually created dead life and wind because we have used 1, 2, 3, 4. 1, 2, 3, 4. 4 is an imposed load. The intention of load case 100 and 200 is supposed to be, this is dead and wind only. This is dead and life. So load case 100 is correct. Dead and life, which is primary load case 1 to 10. 15 is supposed to be dead and wind. So we have done 1 to 10 including life load. So we need to remove life load. This is supposed to be dead and wind in the X. Okay, I'm seeing load case 11 in this combination. Load case 11 is a life load. So 200 is supposed to be dead and wind in the X. 300 is dead and wind in the Z. Okay, they will then do dead life and wind in the X, then dead life and wind in the Z. So let's take away this, let's adjust combination 200 to cater for dead and wind in the X. So anything that is a life load, let's come here and look for life loads. We will remove it from that. Roof slab dead, blah blah. Roof imposed. So look case 4 will go. Take it away. Dead life. Load case 6 would go. Load case 9 would go. Then load case 11 would go. Great. Change. Alright, so this now caters for dead and wind only. Let's adjust combination 300 as well. So 300, we're going to remove load case 4, 6, 9 and 11. So 4, 6, 9 and 11. So this is dead and wind. Change. That's great. So the next thing we're going to do now is dead, life, and wind in the X, then dead, life, and wind in the Z. These are serviceability limit state load combination. Remember. So come here, go call it define combination. This is combination. What do we call it now? So we are in 300, so this is going to be 400. So dead, life, and wind. In this case now you can now select everything in the X only. Then you do combination 500 dead, life, and wind in the Z. Dead, life. Excellent. So in the same way, you're going to create your dead and life for ultimate limit state consideration. So let's just do ultimate limit state combination load case for dead and life only, and we'll design this structure for dead and life load. Let's see how you apply your partial factor of safety. So let's create an ultimate limit state load combination. Add, just the same process. We call these combinations 600. So dead and life. So look, so dead load, you specify factor of safety of 1.4. Life load 1.6. You see, all the dead loads are selected carefully and apply the partial factor of safety of 1.4, and then the life loads are applied 1.6. Once you do, you check it carefully. If you look at your load cases, be very careful. You check all the load cases and ensure that they correspond to the category of load case they are, either imposed or dead load or environmental load, which is wind load or snow load or wave or current load or surcharge load. These are environmental loads. You know, you apply the corresponding factor of safety and then say add, close. Great. Good. So as soon as you're through, save. You go to analysis. You say perform analysis. You say print. So for this case, we need to print statics check. Okay, check for staticity. You add, you close, then you go to your post print, you define, you select the load combinations that you want STAAD to design the structure against. So you are selecting all these serviceability. Okay, so we select the ultimate limit state load combination. So look at 600. Add. Then print analysis results. Add. Close. Then go to design. Now, what is the design code of practice? We are designing to BS 8110. So select BS 8110. Now you're going to watch carefully here. This is where a lot of sensitivity comes into play. The roof beams are what member sizes. So these are 230 by 400, right? Okay. So you're going to define the design parameters. These design parameters are parameters that are contained in the code of practice, which are very crucial for the software to use in designing a structural entity. Information such as cover to reinforcement, trial sizes of reinforcement, sizes of shear reinforcement, sizes of flexural reinforcement, you know, and so on. The characteristic material strength of steel, characteristic material of concrete. These are the critical, crucial engineering technical information that will be specified in this design parameter, which STAAD will use inherently to design your structure after analyzing the structure to reveal the internal stresses or the internal moments, shear forces, and so on. So the first one is asking us, okay, select brace member. What does this mean? This is asking you on your structure. Now look at your structure. What STAAD wants you to do is to select the columns that are braced in either one direction or in two directions or are completely unbraced. How do you know? Simple.